If you are here to learn about making your website faster, then you're in the right room. If you're particularly interested in HTTP2, that's cool too. If you want to see pictures of outer space and stuff, I can provide that as well. So we cater to everybody here. So I'm Marc Drummond, and we're going to be talking about front-end performance and HTTP2. So I work at Lullabot. We do digital strategy, design, and development. We work with Drupal a lot. And yeah, a lot of the projects I work on, I end up working on helping to make the websites faster. And these are complicated websites with lots of media and things like that. And so there's a lot of techniques that get used, and some of those are in flux. And so that's kind of what we're going to be talking about today. I'm going to be focusing on the sort of broader concepts of how things are changing with front-end performance rather than the nitty-gritty coding details. And there will be a link to slides at the end. So if you want to take notes during this, if that's helpful to you, that's great. But don't feel obligated to try to write everything down, because there'll be slides on the Twin Cities Drupal Camp website, and there'll be a link at the end. So, okay. So you have woken up this morning and you decided, this is it. Today is the day I'm going to make my website faster. And so you're like, okay, that's what I'm going to do. This is really good. First, I need some toast, because it's important to start your day with a good breakfast. It's very important, actually. So as you're going to get your toast, you go to the fridge to get your bread, and you're thinking to yourself, okay, the things I need to make my website fast, the things I remember hearing about, I hear about I need to pull all my CSS and JavaScript into just like one or two files. If I have like tons of CSS and JavaScript files, that's a problem. I remember that. So I'm going to try to aggregate those files together. Okay, so you get out the bread, and you're getting ready to slice it. It's looking like pretty good bread. And you're thinking, okay, another thing along those lines I think that I heard was that if I have a lot of images, like icons on my website, I could turn those into an image sprite, just in one image file, and using some complicated CSS to just look at one part of the image that has the icon I want, and then there's only one request between the server and the browser, and that's good. And some people have been using icon fonts, but I think I remember hearing that that's not always awesome, because there are accessibility issues with that. But okay, all right, you're starting to wake up a little bit now, and you get the bread to the toaster, and you're thinking, okay, less files. Less files is good. I remember font files. If I have too many fonts on my website, if I have 80 fonts, that's a lot of fonts, and it's probably not going to look really good if you have 80 fonts. But even if you have just like 2 or 3 fonts, and you have a bunch of different faces of those fonts, and there's a different file for each of those, bold and italic and bold italic, and extra bold, extra bold, like it really gets to be a lot, and there's a lot of files downloaded, and that's a problem. So I might want to avoid that. And then I heard that sometimes if there's some things that are really important, like some really important CSS or JavaScript or images, like things that are right at the top of the page, that you could put those right in the HTML of the page, and that way it just comes right in, and the browser doesn't have to make a request. You can turn an image or a font into a data URI, which sounds like a scary word, but it just means a whole bunch of really, really long characters that the computer understands as a font or an image. And so that you can do. Less talking between the browser and server, kind of a theme here. And so you get your toast, and you're like, okay, I got it. That's what I have to do. I have to minimize the number of requests between the browser and the server, because it's expensive to have all that talking going on. That's an expensive thing. I remember that. And so, all right, that's something I can try to work on. And kind of along those lines, you're like, I need butter on this toast. But you're thinking, okay, there's also a thing that the reason for that is because the browser can only open a certain number of connections with the server at any given time, like 4 or 6 different connections, and it can only be one file going over each of those connections. So I remember hearing that possibly you could split up and have a separate domain name for like your image files and font files and things like that. And that way you can have more connections open at the same time, and multiple things can be downloading at the same time. And that can be good because if you have cookies that you're using to have like personally identified information about a user, if you have those only on your main domain and not on the like assets domain, then that's good because that's overhead on each request. And it's getting complicated, but you're like, okay, but the butter on this toast looks good. And so the other thing is that you can reduce the file size. That's another thing that you can do. You put aside the like talking and talking between the browser and the server. If there's less file coming down the wire, things will be downloading faster. So you're like, okay, what can I do along those lines after I get jam on my toast? Okay, so minify and compress files, that's a thing. So that's something that you don't even have to do. Your server can do mostly. And minifying a file is where you like suck out all the extra space from the file. So all the extra spaces and tabs, I know you're using spaces instead of tabs in your files, but just in case there's a stray tab there somewhere, those get all sucked out. And even it can go further than that. And if you have like a really long JavaScript variable name, that can automatically be turned into like AB or something, and there's all kinds of substitutions, and the file gets small. And you can do compression on images. So like your image compression, for example, maybe by default in Drupal it could be set to like 80%. But you could check it out and say, oh, I could turn that down to 60 to 65%. The images still look pretty good, but the files are like half the size. So those are kind of two things you can do to make file sizes smaller. Okay, yeah, optimizing images. That's kind of what we're talking about. That's one good way to do compression. Another thing you can do to make file sizes smaller is make your fonts smaller. Now, if you have an international website, you might need your font to have a lot of different characters for different languages. But if not, if your audience for the website is not, going to be reading it in Cyrillic, then you can take some of those characters out of your font. You can use a tool like Font Squirrel to help do that. There's lots of different tools that can do that. And if you make your font have less characters in it, then it's smaller and it doesn't take up as much space. So that's another thing that you can do. You can also use a more efficient font format. Really, you only need 2 font formats right now, .woff, W-O-F-F, and WOFF2, W-O-F-F2. And WOFF2 is more efficient by about 20 to 30%. It's not supported by all the browsers, but elsewhere you can read about the syntax to use so that it'll use which one works. And then the other thing you're thinking about is that you really only want to get the JavaScript and CSS that you need for one particular page. You don't want to have every potential CSS and JavaScript thing for your site, because if you don't need that for your page, that's a lot of extra data that's getting downloaded. But you kind of have to weigh that against the fact that we want to minimize the total number of requests to our site. And so we kind of want to bundle our CSS and JavaScript up. And if you download one big bundle for your site with all the stuff you'll ever need, it's a big initial load, but then you don't have to do it on subsequent pages. So you kind of have to balance that out. And it would really be nice if there was a better way to handle that. But I don't know. I guess we'll have to just dream. Or maybe we'll talk about that later. So you're like, okay, I've got my toast, I got my jam. It's really going to be good. But I still need to wake up and I don't have coffee. So that's your next task. Also, critical rendering path. So we've talked about browser requests, we've talked about file sizes. Now we've got to talk about this other thing, which kind of sounds sort of fancy, but it basically means once your browser gets stuff from the web server, how does that actually turn it into pixels on the page that you're actually looking at? How does it look through the HTML that you have and all the little different files that you're sending it, and how does it put a web page together? Because there's different ways that you can order things, and the website will load faster, even if you're delivering exactly the same stuff. So, for example, CSS blocks the rendering of your page. Once you've got CSS going, the browser has to figure out how that works with the HTML on your page and puts them all together and then loads up and makes the website happen. So while it's loading the CSS, it can't really do anything else. Some JavaScript can also block the rendering because that might alter your HTML that's on the page. And so one thing you can do is say, here's the most important CSS and JavaScript for my page, and load that first. So the stuff that's globally at the top of your page, navigation usually, stuff that goes in the header. And if you load that stuff first, then I know they say that there's no fold, but there is a fold on your page. And if the stuff that's at the top of the page is getting painted first, then somebody doesn't even know that down there, stuff isn't, it still needs more CSS and JavaScript to look pretty. So that's one thing you can do, is you can make the CSS and JavaScript load first. That we talked a little bit about inlining CSS and JavaScript, and that's one way to get that stuff to load quicker. And then things that aren't as important that may be showing up, but like in the footer of the page or lower down the page, if you can take that out of the loading path for how things normally get loaded, then that can speed things up. And so there's some complicated techniques for this that involve JavaScript, and there's a really good book, Responsive Web Design, by Scott Gell, that talks about this. The Filament Group is an agency that has a lot of different blog articles about web performance, and they have some really good things about how to do this. And then you can do the same thing with JavaScript. If you have JavaScript that doesn't even work until all of the content on your page is loaded, you don't want it in the head section of your HTML, because that's going to block rendering. You want that at the very end of your page. And ideally, you can put an attribute on there, async and or defer, which says to the browser, hey, this is important, but you can load other things first, and come back to me when you get time. And so those are some things you can do. And by default now in Drupal 8, JavaScript is loaded in the footer by default. That doesn't mean there's not some module out there that's really eager to go and is going to put things in the header. But that's a thing you want to look at, is where your JavaScript is loading. Similarly, you don't necessarily want your fonts. Those can block rendering as well. And font files are tricky because if the browser knows it needs to load a font file, what it can do is make the whole text invisible until the font is available. And if there's a problem loading the font, especially when you're on mobile, then it can block the whole rendering of the page. And you might have seen that, where you see the page load up, but there's like invisible text, and you're like, where's the text? And it can be really problematic if like one of the words uses like a normal font and the other font isn't loading, and then like there's this weird message like that doesn't look, one of the words is in a different font, like italics, and I don't know, strange things happen. So the other thing you can do is you start out with your fallback fonts, your Helveticas, your Verdanas, your Georgia, and you have those set. And then you use JavaScript to load up your fonts. There's a tool called Font Face Observer, and that will help to load all the font stuff. And then once it's loaded, you can like add a class to your body tag that says, fonts all loaded, something like that. And then near CSS, you have your rules set up so that you only use your fancy fonts, your nice little web fonts, when the fonts have actually finished loading. And then the font swaps in. And you can set it up so that whole process doesn't happen on every page load, so that once it's loaded, you can store like either a cookie or a session storage to say, hey, we've already loaded fonts once, they're in the cache, you don't have to do that whole process again. So anyhow, your coffee's looking pretty. This is looking good. It's a good morning here. Other thing you can do that with images too. If you have a really image-intensive website, if you have a 200 image page, that is going to slow things down. So what you can do is if you have like a grid of like news stories with images at the bottom of the page, you might choose to not have those images load in immediately and then use some JavaScript. So as somebody's scrolling down the page, it puts the image element in there, and then the image will start loading. And there's pluses and minuses to that, but that's another tool to make your website faster. So all right, we got our breakfast. We're all ready to sit on the porch and just think about the things we're going to do to make our website faster. So we talked about bandwidth, file size, right? We can make that smaller. We can make the critical path of how things load faster. We load the most important things first. We load less important things later. And then we have to keep in mind these limited simultaneous requests. And so it's worth taking a minute to think about this a little bit more, about what that means when we're talking about minimizing requests between the browser and the server. So you can kind of think about each request as a conversation. So the browser says to the server, hey, I'm the browser. I would like that page. And the server says, hey, I'm the server. And the browser's like, hi, server. And the server's like, hey, here's my password. Here's my credentials. And the browser's like, oh, yeah, that's your password. This is HTTPS. Can you send me the HTTPS stuff? And so it's like this whole conversation. And your browser can have multiple connections open, but it has to have that conversation every single time. And in theory, those connections can persist after you get one file delivered over it. But there's a lot of overhead to each conversation that goes on. And the browser can like start talking about, here's my viewport size, and I'm Internet Explorer, and like all this stuff. And they're like, here's my cookies. Look at all my cookies. They're great. So it can be a very arduous conversation to have happen over and over again. And because of these limited connections, what you'll see is has anybody ever used DevTools and gone to like the network tab and looked at the performance? And you've seen that waterfall, right, of how things load in as they go. And that's why this is happening, is because some files have to finish loading before the next group of files can load, and the next group of files, and the next group of files. And so, that's kind of a challenge. But you're all good. We totally understand what we need to do now to make our website faster. We've got a plan. We've got some tasks that are ahead of us, and we are ready to get things going and being really fast. And what's that? Oh my gosh, it's coming towards us. It's HTTP2. Ah! And like the ship lands, and somebody gets out of there, and they start yelling at you, it is time to multiplex your requests. And you're like, what does that mean? And then it starts yelling, compress your headers with HPAC or else. And you're like, I don't know what's going on. Minimize your round trips with server push. And you're like, oh my gosh, this is like, I thought I knew what was going on. Prioritize your assets with weights and dependencies. It's just like really getting overwhelming here. And then, we've had these specs on file with the IETF for years. You should have been better prepared. And you have just about had it at that moment. But that's when your friend stops by, Portia, and Portia Centurion says, don't panic. Everything is going to be okay. And you're really happy because your friend has a good way of calming you down and says, it's all going to be okay. I've got this. And so she goes, and you're all putting your thumbs out and doing some, she's like, we're going to do some hitchhiking. It's going to be okay here. And so you're just teleported up to this spaceship, which is strange. That doesn't happen most days. And she's like, we've got this. I've got this hitchhiker's guide to HTTP2. And it's going to explain everything. We're going to be totally fine here. just don't panic. So you open up the Hitchhiker's Guide to HTTP2, and it says it is time to unlearn what we thought we knew about front-end performance. And that's a little bit scary because you thought you knew things, but it's oddly calming. And so you're like, all right, I'll go with this. And it says, let's begin by talking about multiplexing. And multiplexing is that you have one connection between the browser and the server, not 4, not 6, not connections that open and close. You have one persistent connection between one browser and one server, and you can send multiple streams through that connection. And those streams contain messages which are split into frames. And this is still a lot of words, but it explains that a frame is a certain chunk of files, and a message contains metadata about that chunk of a file. And so the whole thing means that you can send multiple files over one connection without all that overhead that we were talking about, where you had multiple connections going on. And this is sounding good. So then it says HPAC header compression. Make sure not to yell that. HPAC header compression is complicated, but basically means there's less overhead per request. Rather than having that long, involved conversation at the beginning of each file request, that all can get compressed down and happens once for the whole connection. So the browser doesn't have to keep explaining who it is over and over and over again. And so that's less data that's going over the network, and things can load more quickly. And that all happens behind the scenes. It's not something you have to do anything about. Server push is that when your browser asks for a particular web page, the server can be configured to say, hey, it looks like you need a web page. Here's these other 5 files that I know you're going to need as well. Here's some CSS and JavaScript that I'm just absolutely super duper sure that you're going to need. Have them. And the browser's like, okay, all right, here you go. And reads the HTML and is like, oh, there's the file I needed, and can then start using it. So that can be faster than when we were inlining files for our critical CSS and JavaScript, because it's going over the network, but instead of getting embedded in the HTML and then getting that same HTML loading every single time you go to the page with all that file data in there, it's getting pushed from the server once. And you don't have to load it in your HTML every time. And there's some caveats to that, which we'll come back to. Prioritized delivery of assets simply means that the server does some work to figure out which things you're going to need more than others. So HTML, it's probably going to say that's really important stuff, because I can't show you anything without HTML. And CSS, it's probably going to say that's pretty important too. And JavaScript, yeah, that's good. So it'll put some priorities on different things. So if you've got this whole big pipe of files and it's getting broken down into little chunks of data, it's going to decide how much of that pipe to use at any given time for the different types of chunks. So it could say 50% of the pipe goes to HTML, 30% goes to CSS, 20% to JavaScript, 10% to other things. And I'm not saying that those are the actual percentages, but that's kind of, it prioritizes things. And it can understand dependencies, so it can know that if I'm going to send you this CSS file, that CSS file asks for these 4 background images, so I better send you those images as well in order for the CSS to work. So it can kind of do some smart things behind the scenes that, again, you don't really have to set up yourself to make that happen. And as you're reading this, you're feeling calmer, but then the planet blows up, and Earth is gone, which is kind of a bummer. And Portia's like, yeah, those best practices you thought you knew, those are gone. And so is the Earth. Which, she's like, don't worry, we'll find a new home. And you're like, okay, I'm going to stay calm, I'm not going to panic. And so we head out into the universe to find a new planet to live on with new front-end development practices. So you have a long journey ahead of you as you head out into the solar system. So you have some time to think a little bit now. what are the consequences of these changes with HTTP2? And so the performance practices that we had were based on optimizing based on the restrictions that we had, based on how HTTP, this protocol developed over years and years. We were based on the limits of that protocol, but now we have a new one, which is HTTP2, and it has different limits. So we want to rethink based on those limits as to how we optimize things. So one of the things that's really clear is that requests are less expensive. You don't have quite as high a cost for every single file request that you have. And that's what we were doing a lot of optimizations around that before. So we might want to rethink that. Because if we're bundling things into giant bundles of files and it's delivering data that you might not necessarily need for a particular page, before we were doing that because there was a good reason, because requests were expensive. But now that's not necessarily the case anymore. So we kind of want to think about that and think about what are some of the things we might want to do about that. Inlining, we were putting CSS and JavaScript and all kinds of things right in the file because it was expensive to communicate with the server. Does that still make sense? So we're going to explore our options for how we can do things in a new way with HTTP2. So the first thing that we have to do to explore this is we have to turn on HTTP2, which in hindsight was pretty obvious. We should have thought about that beforehand. But if we want to turn on HTTP2 on our server, we need HTTPS. So HTTPS, making your website secure, that's really important anyways, because Google is starting to rate websites based on whether they are HTTPS, and it's becoming more and more important that really everything gets delivered as HTTPS anyways. So it's a good thing to learn about. There are good tools out there where it's less complicated than it used to be. There's a tool called Let's Encrypt that's put out by the Mozilla Foundation that makes it possible to get a free certificate for security. And that doesn't magically make everything work in a simple way, but it's easier than it used to be. And so that's something that you'll want to look into if this is something that you explore. So we're getting out towards Jupyter now, and we think about how we're going to unbundle all these files. If we don't have to aggregate them all together, what are we going to do? So ideally, we would deliver just the CSS and the JavaScript that's relevant for the page that we are on. And we'll have to think about, is that possible? Can we do that? But ideally, then if you can break things out into multiple files, then you don't have to download 250K of CSS, which would be a lot, when you might only need 50K for your particular page. And then when you get to the next page, then you download the CSS that you need for that you didn't have before. Image sprites and icon fonts, I think we can safely say goodbye to those. Those were mostly used for icons anyhow, and SVGs are very, very well supported by all browsers. And so SVGs are a text-based format. It's XML, and it creates a vector file like you would with Illustrator, a file that can be scaled to any size, and it's going to look nice and crisp. And it's good for icons and things like that. So SVGs are good, and we should use them pretty much everywhere. It's a lot easier than having to figure out how to do an image sprite. So easier is nice, I think. So bundling font files into a really long, complicated data URI, I think we can probably say goodbye to that now. There may still be some circumstances where it provides an optimization, and so if it's really essential, you could keep doing it. But we were doing that in order to avoid a request between the browser and the server. And so if you're using HTTP2, I don't really think that makes as much sense anymore. A data URI is bigger than an actual font file. It's about 10 to 20% bigger. And so we save some file size. It's less complicated. Life is good. Improving the critical path. That was one of the other big topics we were talking about. So server push. Server push has some complications because it sends you files you need when you request a web page, but it sends them every time you request a web page. Every time you go there, it doesn't know what files you already have. It doesn't understand browser caches. So it's just like, you requested index.html. Here's these 5 files. Then you come back, and you're at index.html. Here are these 5 files. And it doesn't have any ability to say, oh, that was in the cache. So there's some challenges with taking advantage of server push at this point. And we'll talk about some things that might be on the horizon to help with that. Another tool, which is cool, is you can have a link element in the head of your HTML that has an attribute called rel equals preload, and you need another one that says as equals, and then the font, the file format. So what this does is, this is a way to say to the browser, hey, this particular file, this is important. I want you to get started loading this right away. And it doesn't actually load the file. Like, you could put in a CSS file that's really important, or a font that you're definitely going to need. And it'll get started downloading, but it's not actually going to execute the file. But later on, when you have an instruction to use that file, it'll say, hey, this is there. So in a way, it's kind of like server push. It skips. It's not quite as fast as server push, but it's a way to say, hey, this is a priority, and the browser will pay attention to caching with that. And that's getting more support. It's I believe it's in Chrome. I don't think it's in Firefox yet. It is going to be in Safari this fall. So it's coming along, and I think Edge will probably get it in there pretty soon too. So I think that's an optimization we can probably start taking advantage of. And again, I kind of mentioned inlining versus caching. That the inlining is something that probably let's say goodbye to that best practice, because it bloats up the HTML, and that gets downloaded every time. I mean, there's some fancy things you can do to avoid that, like using a cookie to say, hey, I've already loaded this page, I don't, and then change your HTML. But it's very complicated, and I think, like, if we're working with Drupal, I think that'd be pretty hard to implement. So I think inlining is something that is probably going to be a thing of the past. But there's a lot of things that are not a thing of the past. There's a lot of front-end performance best practices that we're going to just keep on doing. We talked about optimizing images, right? Like, if you are in Drupal and you go to, there's a image optimization setting, you're going to still want to do that. That's not something that changes. Smaller file sizes are actually probably more important than ever, because that's really the biggest limiter right now is file sizes rather than requests. I didn't mention this earlier, but CDNs are still important. So CDNs, a content delivery network. So speed of light is fast, but it still takes a while to get all the way from Saturn to here. It has to travel a distance. And Earth, distances aren't free for light either. It will take time to go from one side of the planet to the other. Maybe 150 to 200 milliseconds. Now, that might not sound like a lot, but if you add that up for every single file, where there's a delay of every single file, it only takes 6 to 10 of those delays, and now you've had a full minute where, it adds up. I'm tired and I'm not doing the math right now, but it does add up. I promise you that. So yeah, we measure in seconds more than minutes. A second is a really big deal. A 1 second delay is a very big deal. So a CDN solves that by putting servers all over the planet, so that things, even though they're traveling electronically and that's fast, it's not instant. And so by putting servers closer to where you physically are, then files will travel faster. That's still totally important. And if you have a large website, you almost certainly need one of those. Akamai is a big one. Cloudflare is a big one. Another thing that's still important is, we haven't really talked about how you make your site faster on the back end, but all of those things, nothing's really changed with HTTP 2. One common technique that you'll see is varnish. Have people heard of varnish? Used varnish? Probably a lot of people, right? So varnish itself is good to know. So Varnish sits in between your browser and your server. And it says, hey, browser, you want this? Well, I've got that for you. Here's this file. It's important to know that Varnish itself does not speak HTTP2, and it may never speak HTTP2. So you need to have another proxy in front of Varnish. So some setups use an Nginx proxy, for example, to take the files from Varnish and then spit them out as HTTP2. So hopefully you don't need to configure that. Hopefully whoever you're working with for your website can help make that happen. But it's probably good to know that that's a thing. The other thing is you might be wondering, well, okay, well, what if I'm making all these optimizations and people can't get those optimizations because they're not supported? And in theory, yes, there may be some very old browsers out there that don't support HTTP2. But really, if it's very, very well supported, I believe it's well upwards of 95% of people can use HTTP2 in their browsers these days. So there's a small percentage that might not. And in theory, you could say, well, it's important to cater to those people too, and so we should optimize for them. But then 95% of the people that are going to your site get a slower site. Now, in theory, you can do some complex optimizations where you might detect whether somebody is using HTTP 1 or 2, and then like change around your HTML and your whole delivery strategy based on that. But that's very, very complex. And complexity often means that things don't actually happen at all. So while if you're in a very, very high traffic situation where even a small percentage is big numbers of people, you know, maybe it's worth considering. But I think we're at a point now where we can optimize for HTTP2. So what about that? What about how do we know if this is supported or not? We're leaving the solar system now. We decided none of the planets here work, so we're going to look for a new planet elsewhere. And while we're doing so, we're going to do some research. And we're going to look at, so server support is very good at this point. A couple of years ago, it was shaky. It was just getting implemented. But right now, it's really good. There's support out there for Apache, Nginx, pretty much all the things. H2O is kind of a newer server that was built specifically to demonstrate optimizations for HTTP2. And so that's kind of like the cutting edge sort of thing. But all the other servers support it at this point. Now, whether your particular hosting provider supports it is probably another thing. And so I'm not sure that everybody has, all hosting providers have that turned on at this point. But it's something to talk to them about because there are very big optimizations that can happen. Your website can be a lot faster with HTTP2. So it's something to talk to them about. And like I said, browser support at this point is very good. Chrome, Firefox, Edge, pretty much everybody's on the most recent version with those. That's well supported. It's in Opera. Safari 10.11, which I think is El Capitan, the version before now. So it's been out there for a while. There's good support for that. Windows 10, if you have Windows 10, then it's supported even in Internet Explorer. You can't really blame Internet Explorer on this one. CDNs, they were kind of at the forefront of supporting HTTP2. So if you're using Cloudflare or Akamai or AWS CloudFront or Fastly or probably almost any other CDN, they are supporting that. So even if your hosting provider isn't, if they're not directly having their servers support HTTP2, if you're using a CDN, you may still be able to optimize for HTTP2. So what have other people found? So on your spaceship, you find a robot who looks pretty sad, and so it's Marwin the robot, and it's going to tell you that there's some sad things that you need to know about HTTP2, about people who tried to optimize it and had some challenges. So Khan Academy has this case study where they tried to optimize, and they had 25 JavaScript files roughly, and they really really unbundled things and went to 300 JavaScript files, and the website got slower. And I would say that they maybe unbundled too far, that might be too much. They had 25 JavaScript things for different components on their page, and then they're like, well, we'll break it down even further than that. And they might have been better off if they had just stuck with optimizing for 25. So yeah, there's another one, 99 designs, and they have really image-heavy pages. And so they tested between HTTP 1 and HTTP 2, and they found in some cases it was slower. But when you dug into their case study, to me it looked like, well, maybe they didn't have a very good font loading strategy. And you remember how before I talked about how if your font loading isn't optimized, then it can block everything. And it looked to me like that's probably what happened. And so I wouldn't throw out HTTP2 because of this particular case studies. There's a lot of CDNs that have done demos of this because, again, they were some of at the forefront of this. And they have a lot of things where they show that pages generally load faster if you have HTTP2 because you have a bunch of files downloading at the same time rather than that waterfall of pages loading in over multiple connections. So this is kind of interesting when people compare HTTP1 and HTTP2, but I kind of think it's not necessarily the right thing to be testing at this point, because as we go forward, I think servers and CDNs and hosting providers the default is going to be HTTP2. I don't think you're going to be sitting here and making a decision, should I use HTTP1 or HTTP2? I think you're going to have HTTP2. I wish that there'd be more case studies that were done on, okay, we're using HTTP2, what are some differences in strategies and how that makes things faster? Because I think in the long term, that's really what we need to be able to figure out our new best practices. So I kind of like this quote. So unbundling has limits. So this is a tweet from Cramforce where he said, common misconception, HTTP2 makes concurrent network requests free. And so you can do about 10 times more requests, but not 100 times. So that example of Khan Academy, where they went to 300 files, well, that's maybe too many, right? Like before, you might have optimized down to like 3 JavaScript files. And so when they were at 25, they were good. They were at about 10 times that. But when they went to 300, maybe that's a limit. Because there's still, there's less network overhead for each file, but there's still work that has to be done for each file. So if you have 1,000 files that you're going to download, that's probably going to be too many. But if you have a few dozen files, you're probably going to be okay. So, part of the reason why is that compression was one of the things that we talked about. So unbundling may reduce that a little bit. I kind of talked about how in a particular JavaScript file, you might have substitutions for little bits of the file, right? Where it might find a common pattern of a variable name that gets used or a particular pattern in your code, and then find like a short code to use to compress that. So if you have the same amount of code in 10 files instead of 2, there's going to be less times where those patterns repeat. And so there's going to probably be less compression because of that, because there's less substitution that can happen. But there's still going to be some substitution that can happen, and it's going to depend on your site. So I still think that there's a value in unbundling files to some extent. But how do we do that? How do we figure out, how do we navigate this new nebula of figuring out what do we do with this unbundling? How do we figure out how many files we have, and how do we separate out what's in one file from another file? So one thing you could look at is cache invalidation, which one of the 2 problems of computer science. Cache invalidation is that how do I know that I need to have a new version of this file so that I don't get an old version of this file? And and you want to have fresh content. So one thing you might do is separate out things that are stable files that aren't going to change very often from unstable files. So if you have some vendor files like jQuery or something like that, that are probably going to stay fairly static for a long period of time, maybe you bundle all those up together. And then the things like, especially if you're in development mode on a site, some of your CSS might be changing more frequently. So maybe you don't bundle, well, you're not going to bundle your JS and CSS together anyways, but you might do some separation that way of your custom code versus some contributed code. And that might be useful. Another thing to look at is, do I want to bundle things per page? Do I want all the things for the home page bundled together? And all the things for a landing page and all the things for a blog page, and have separate bundles based on that. And I think that's helpful, but you're still going to have overlap of some things probably that are used on a home page versus an article page versus a landing page. So I think components, breaking things down into components, are helpful. Have people done things with component-based theming, with BEM, trying to break your website into different chunks of a page, right? So your navigation, your header navigation, your footer, your actual like the top of a blog article, each of those might be their own component. So if you can break things down, which you might already be doing with if you're using Sass and you're breaking things down into multiple components, that may be a good place to start. Just delivering all the stuff for one particular component at a time, and that it depends on your site. I would say on most of the sites that I've worked with, even complicated sites, how many components are there? 20 components? 30 components, maybe? I think that's for a pretty complicated site. So if you had that number of files that were out there that you've broken things down into, then that might work. So, and the question is, how do you get it so that the CSS and JavaScript for a particular component are delivered when it's used? And the good news here is that Drupal 8 is a really good tool for this. There's some things in the horizon that people are looking at, like putting a different style CSS thing in the body to embed your styles that way, or using web components, which is a technology that is on the pretty near horizon that we might be able to use. But if you're using Drupal 8, you have the ability to set up multiple libraries for CSS and JavaScript. And you can attach those to the individual component you're using. If you're using a Twig template, for example, you can call for the library assets to be attached when that HTML gets loaded. So there's some really good tools in Drupal 8 to break this up into multiple things. And I don't know that I'd rely upon, I don't know that means that I'd turn off aggregation on Drupal 8 entirely, because especially if you're using a bunch of contributed modules, is that going to be totally optimized? I don't know. But you have an ability when you define libraries there's an attribute you can put on a CSS or JavaScript file that says preprocess is false, and that'll turn off aggregation for that particular item. So I think that's something to explore. So going back to server push, that has some challenges. So why is server push a challenge? So server push is kind of like a black hole. So once you push things into a black hole, it goes over to the event horizon, you're not getting that back, right? So it's kind of the same thing with server push, is that once you put assets into the server push stream that's going down, they are going down from the browser to the server, and they're going to take up space in that pipe no matter what. If that file's already in your cache, it's still going down there. If you decide, hey, there's something more important I need to send, sorry, that's in the pipeline, that's going down there. And so I've seen some approaches that are like, okay, we can use server push. Let's just push all of our CSS and JavaScript for our site. And I think that's a problem, one, because it's going to really happen on every single page load. And two, it's going to block all the rendering while that stuff is getting downloaded once it's on its way. And so I think that is kind of a problematic approach. I think server push might have some of its uses, But right now, I think that's kind of a little bit challenging. So like I said, it's pushed on every single request, which is a problem. I've seen some people who've jiggered complex solutions where they set a cookie if something's been pushed and then uses that to determine on the server whether to push something or not. It all sounds very complicated to me. If you really want to dig into complicated server things, might be possible. But I really think that server push seems like a technology that's very well designed for single page apps, right? If you're using like a JavaScript framework and there's one request and somebody goes there, sure, send the assets right away because there's really only going to be one request. When somebody goes to a new page, it's just using JavaScript then to get the new data. It's not doing a new request and downloading all those assets again. I think it could be very good in that sort of situation. But if you're working with a content-based Drupal site that's using standard theming and you're going between multiple pages, I think you're going to get a lot of overhead with server push. But there's a cool thing that's coming down the road called cache digest, and this is still being developed. But this is a way where when the browser sends up a request, it could have like a very compressed list of here's the files that I have cached related to this particular server. And then when the server gets that, then it could say, oh, okay, I'm going to check the files I was going to push against that list and decide not to push something if it's in cache. Right now, it doesn't have an ability to do that. But I think this could be really exciting because if this happens, then server push becomes a really useful tool. So cache digest, that's something to keep your eye on. Service workers. This is kind of an adjacent technology that's not based on HTTP2. But I've seen some people talking about it as a way to maybe address some of the challenges of server push. So have people heard of service workers? It's a JavaScript thing. It's kind of new. So if you haven't, it's totally fine because this is really brand new. And so service workers are something where once it gets downloaded from the server to the browser, it actually lives on your computer as a client. And it sits in between your browser and your server. And then when the browser says, hey, I want this particular file, the service worker can say, hey, well, I cached that file earlier for you, and I'm going to give you that file out of the cache rather than asking the server for it. So I've heard some people talk about, well, we could push the assets to the service worker, and then the worker will deliver those assets on future requests. But that really only works if the service worker is caching the HTML too. If you have a dynamic site where you want people to see your new blog posts or your new content, and it's changing frequently, then you're probably not going to want your HTML cached on a person's browser, like permanently, like that's where everything goes. So if you have a very static site, yeah, I think that could be something that you could explore, but I think that's maybe not going to solve everything. Okay, so we've talked about a lot of challenges and thought about a lot of different things. How do we put this together? How do we think about what are we going to do for going forward? We're going to really dig down and try to find the exoplanets that we're going to live on right now. So, so partial bundles, I think, is breaking your CSS and JavaScript into smaller bits. I think that's a very good thing to explore now. I think we should do that. And I think Drupal 8 has some really good tools that can help with that. I think a lot of people might be in a situation where how they actually deliver that may be very difficult, but we're in a really good position with Drupal 8 where we can actually do per component CSS and JavaScript. We can have our Sass render out separate files for each component and then put those in a separate library and attach those to a particular template file or do it in pre-process so that when the particular component is delivered, the library file gets attached. And so a lot of other systems out there might not have that ability, but we do. So I think we could think about breaking things up a little bit further. If you have a bunch of components that always appear in the header, I think you could bundle those ones together because they're appearing as a group, right? So you could group things a little bit. And I group your global stuff in the header separately from the stuff that's in the footer because the stuff in the header is going to display a lot faster. So that's where you might think of some way to telling the server, hey, this is more important, we want to download this first. In theory, if you have some very stable vendor assets that aren't going to change over time, you could also bundle those separately because they're not going to change often, and so you can set a long max age on those, and it won't get updated very often. That's fine. Icon fonts and image sprites, let's say goodbye to those and use SVGs. I didn't talk much about this yet, but responsive images are a really good technique to make your website faster, where you're using some HTML to tell the browser, hey, here's multiple image files, and they each have a certain size, and here's the amount of space it's going to take up, and now you, browser, pick which file to download that will have just the right amount of data. So that's a really good performance technique that you should definitely be using right now. Server push, I'd say keep an eye on it. I don't know that it's ready for prime time yet unless you have a very specific circumstance. Cache digest will help with that. Service workers, if you have a static site, that could help. Another technology, link preload. I think that's an interesting thing, and especially with support coming out in Safari now, it's becoming more useful. So you might want to think about that. You don't want to put 20 link preload files at the beginning of your page because that'll gum up the works. But like maybe one serif font and one sans serif font file, just to like get something in the works, and maybe like your critical CSS and your critical JavaScript. You know, just like 3 or 4 things that you might want to preload. Font Face Observer is a really good tool, and I highly recommend using it. Zach Leatherman has written some really good articles about font loading technologies, and I'd encourage you to take a look at that. There's a new technology called Font Display. So Font Face Observer is this independent third-party JavaScript thing that you put on your site. Font Display will do that same thing automatically in the browser. Font Display is going to be a CSS property that lets you say, hey, once fonts have loaded, switch fonts. And so that's coming. It's been coming for a while. In theory, it will be here in the next couple years or so. But something to keep an eye on. So I'm excited. I think we have some really, really cool things that are coming on the horizon. And what I really think is exciting is that things are getting simpler. When I was talking in the beginning about here's all these things that you can do to make your website faster, I find a lot of those things to be pretty complicated, right? And when they're complicated and you're on a project and you have deadlines and you have a certain amount of time, complicated things sometimes don't get done. And then your website's not as fast. And simpler things are easier for more people to do, and so they actually happen. So I think that's great. I think there's a lot of things that are going to take a load off our minds and make website performance stuff a lot faster. So what I want to kind of finish with is encouraging you to all experiment with stuff. So we finish our journey. It's kind of funny, actually. We end up at this planet, and inside of it, they're building other planets. And it turns out that the Earth was destroyed, but it has to be replaced because it was a computer that was calculating the secret to the life, the universe, and everything. And it got blown up right before the answer. Well, they knew the answer, actually. Sorry, there was an earlier computer that figured out that the secret to life, the universe, and everything was 42. But we didn't know, well, what is the question that has the answer of 42? And Earth was calculating that, and it got blown up, which is a problem. So they built a new Earth to be able to finish that answer. And I actually have that answer for you as to what the secret to life, the universe, and everything. So this is like an extra bonus, right? Who knew you'd figure that out by coming to this session? But you did. So Douglas Adams wrote The Hitchhiker's Guide to the Galaxy, which is kind of what I based the theme of this talk on. And so he knew about computers and programming and things like that. And 42 is actually an ASCII code for an asterisk. And so the answer to life, the universe, and everything is an asterisk. It's substitute what you want it to be here, right? that we each have to figure out the answer to life, the universe, and everything. And so that's what I want you to do with front-end performance stuff. I want you to experiment and find your own solutions. I can't tell you right now what are the new best practices. I can't give you the new planet we're going to live on yet. We all have to still do some experimentation to figure that out together. And I hope you share, if you do try something new, share it. Share with others, because we have to figure this out together. So that's what I wanted to talk about today. I'm Marc Drummond. You can reach me on Twitter. Rarely I write something on my personal website. And there's if you want to have that complicated URL to write down, you certainly can. Or you can go to the Twin Cities Drupal Camp website, where I will post a link to my slides, which may be easier for you. So if you have any questions, feel free to talk to me. I'll be at the event this evening, and I hope you have a wonderful day. Thank you.